Hi all, this video is going to be about properties of exponents, and what we're going to do is we're going to go through each of the properties individually to make sure that we know how to use them correctly before we get to problems where you have to use more than one property at once. So let's take a look at the first question here. It says, multiply, simplify your answer as much as possible. So here we're multiplying two terms, and whenever you have variables with exponents and you're multiplying, you actually add the exponents. Okay, so I know it kind of gets confusing sometimes because as you can see here, there's some coefficients in the front. But what you're going to do, those coefficients are numbers, and you're going to treat them as you normally would. So if I were to multiply negative 7 and 3, multiply those two numbers together, I get negative 21. Now I see the y to the 6 and y squared. So those variables have exponents. And so like I said, when you're multiplying, you add those exponents. So this becomes y, so keep that variable, and 6 plus 2 gives me 8. And if you're not understanding why that works, y to the 6 means that you have 6 y's. And when I multiply by 2 more y's, notice I have 6 here, I have 2 here, so there's a total of 8 y's. So that's why it becomes y to the 8th. Alright, let's look at the power rule. So for the second one, it says we're going to simplify, and if you notice, there is an exponent outside the parentheses there. So I know probably from other courses or from your educational history, when you see 4x to the third, hopefully that will resonate with you as being the same thing as 4x times 4x times 4x, right? And so typically when you do stuff like that, you know that it means multiply by itself 3 times. Now that will work in this particular case, but if your exponent's much higher than that, like 10 or 12 or 14 or anything higher, you're not going to want to write it out that many times. And this is why the power rule comes in handy. And so what you want to know here is that when you have when you have a variable with an exponent raised to another power, you multiply the exponents. So this 3 here kind of, if you want to think about it, like kind of goes to both of those, distributes to both of those. But be careful, because this is actually the same thing as 4 to the third power. Okay, it does not mean 4 times 3. It's still power. And you can kind of think of it as like 4 to the first power there. So if I rewrite this a little bit bigger, this is what it's equivalent to. And so you multiply the exponents. So the 1 times 3 gives me 4 to the third, and then I have 1 times 3 of these exponents gives me x to the third. And then you want to simplify further, so 4 to the third is 64, and then I have x to the third. And if you want to kind of go back to this over here, right, what we originally started with, you'll see you get the same answer. So if I multiply just the coefficients, 4 times 4 times 4 gives me 64. And again, when you're multiplying variables here, you add the exponents. So 1 plus 1 plus 1 gives me x to the third. So hopefully that makes sense. But the power rule basically states that you, if you have a variable or you have something with an exponent raised to another power, so a power to a power, you multiply the exponents. Alright, the third question here is the quotient rule. And so here we're dividing, and so for multiplication you added, for division you will subtract the exponents. But just like before, you want to treat the coefficients as you normally would. So this first part here with the 30 divided by 6, we're just going to divide those, so that gives me 5. Alright, and then I see y to the 6 divided by y squared. So those have the same base, right? So y, and then we're going to keep that, and then we're going to subtract the exponents. So 6 minus 2 gives me 4. And again, if you want to write it out the long way, y to the 6 is the same thing as 6y's. And when you're dividing, you're dividing by 2y's. You can see that those y's cancel, and we are left with 4y's, which is why we have that 4 there. All right, and the last one we're going to talk about today is the negative exponent. Now, typically, when we have a negative exponent, so I'm just going to make something up here like a to the negative third, what that means is you take the reciprocal of the base. So in this case, the base is a, and what that means is, as a fraction, it's like a over 1. So if I take the reciprocal of that, that becomes 1 over a, because I'm flipping it. Reciprocal means to flip. And you keep the exponent, but it becomes a positive because that negative means that you have flipped it. Now here's the thing. Whenever you're working with negative exponents, you need to make sure you understand what base has that negative exponent. And so what I mean by that is, if I look at this problem here, the only thing that has a negative exponent is the v. So that negative 4 you see out front, in front of that v, is a coefficient. It is not part of the base, okay? So only the v has an exponent of negative 4. But if you also notice, the v is in the bottom of this fraction. So remember, when we take the reciprocal, if we look back at this problem on this side here, the a was originally up top and it went to the bottom. Well, if it's on the bottom, then it's going to go to the top. So this is going to become, if we leave everything else the same, the v is no longer going to be on the bottom, it's going to be up top, and then the exponent becomes positive because we have switched it from the bottom to the top. And then if we want to simplify this a little further, we don't typically write the 1 in front, so we would just have v to the 4th over negative 4, and that will be my answer.